Smart Child Zone presents Basic Electricity. Each substance in this universe is made of plenty of atoms, and each atom has the same number of negative electrons and positive protons. As a result, we can say that each neutral substance has the same number of electrons and protons in it. The protons are immovable and strongly attached to the nucleus of the atoms. Electrons are also bounded to atoms, and orbiting around the nucleus at different distinct levels. But some of the electrons can move freely, or can come out from their orbit due to external influences. These free and as well as loosely bonded electrons cause electricity. Electricity is the flow of electrical charge through a conductor. It is a type of energy that can build up in one place, or flow from one place to another. When electricity gathers in one place, it is known as static electricity. The word static means something that does not move. Electricity that moves from one place to another is called current electricity. Calculate the electric current passing through the circuit in which the voltage and resistance is 25 volts and 5 ohm respectively. Here, we have to apply Ohm's law formula. Thus the value of electric current is 5 ampere. Find the current through a person and identify the likely effect on her if she touches a 120 volts AC source. 1. If she is standing on a rubber mat and offers a total resistance of 300 kilo ohmega. 2. This is a small current and will have no effect, since it is below the threshold of sensation. 2. If she is standing barefoot on wet grass and has a resistance of only 4,500 ohms. Such a current will cause a muscular contraction for the duration of the shock. A defibrillator sends a 6.00 amp current through the chest of a patient by applying a 10,000 volt potential as in the figure below. What is the resistance of the path? A defibrillator passes 12.0 amp of current through the torso of a person for 0.0100 seconds. How much charge moves? How many electrons pass through the wires connected to the patient? A large carbon-zinc dry cell is used in physics lab to supply 2.00 amp to a circuit. A voltmeter connected in parallel across the cells reads 1.5 volts in an open circuit, and 1.34 volts in a closed circuit, when the cell supplies 2.00 amp to the circuit. Determine the internal resistance of this carbon-zinc dry cells. B. How much electric power does the cell produce? C. What power goes into its load? The voltage measured in an open circuit is the EMF of the cell, and the voltage measure in the closed circuit is the terminal voltage. A house using electrical tools as listed in the following table. How much electrical energy is used for 1 month? These are what we know from the table. Electric energy is given as electric power times time. So, we can now get the total energy by adding the energies used by the tools. Lightning is a very good example of natural current. In typical lightning, there is 10 raised to power 9 joules energy transfer across the potential difference of 5 times 10 raised to 7 volts during a time interval of 0.2 seconds. Using this information, estimate the following quantities. A. Total amount of charge transferred between cloud and ground. B. The current in the lightning bolt. C. The power delivered in 0.2 seconds. Here are the given data from the information. So, charge equals 20 coulombs, current equals 100 amps, and power equals 5 gigawatts. The resistance of a nichrome wire at 0 degrees Celsius is 10 ohms. If its temperature coefficient of resistance is 0.004 per Celsius, find its resistance at boiling point of water. Comment on the result. As the temperature increases, the resistance of the wire also increases. The rod given in the figure is made up of 2 different materials. Both have square cross-sections of 3 mm side. The resistivity of the first material is 4 times 10 raised to -3 ohms meter, and it is 25 centimeters long. While second material has resistivity of 5 times 10 raised to -3 ohms meter, and is of 70 centimeters long. What is the resistivity of rod between its ends? Here are the given data from the information. The resistivity of the rod between its ends is 500 ohms. The current through an element is shown in the figure. Determine the total charge that passed through the element at the time of 0 seconds, 2 seconds, and 5 seconds. At the time of 0 seconds, the charge is 0 coulombs. At 2 seconds, the charge is 10 coulombs. At 5 seconds the charge is 0 coulombs. Compute the current in the wire if a charge of 120 coulomb is flowing through a copper wire in 1 minute. A potential difference across 24 ohms resistor is 12 volts. What is the current through the resistor? Calculate the equivalent resistance for the circuit which is connected to 24 volts battery, and also find the potential difference across 4 ohms and 6 ohms resistors in the circuit. Since the resistors are connected in series, the effective resistance in the circuit. Calculate the equivalent resistance in the following circuit, and also find the current I1, and I2 in the given circuit. Since the resistances are connected in parallel, therefore, the equivalent resistance in the circuit is the resistors are connected in parallel, the potential across each resistor is the same. The current I is the total of the currents in the two branches. Then, I equals I1 plus I2 equals 6 amp plus 4 amp equals 10 amp. An electric heater is rated 220 volts, 550 watt. Calculate the electrical energy consumed in 3 hours. Storage battery of a car has an EMF of 12 volts. If the internal resistance of the battery is 0.4 ohm, what is the maximum current that can be drawn from the battery? If a current of 3.0 amp passes through an appliance for 1 hour and 30 minutes, how much electrical charge is transferred in the process? How long will it take, in minutes and seconds, for an electrical circuit current of 20.0 amp to transfer 5,000 coulomb of charge? An electric motor of a model car is powered by a 1.5 volt battery. If 120 coulomb of charge passes through the motor circuit in the moving car, how much energy is transferred? For more videos and other useful materials, visit us at www.smartchildzone.com/videos. Register your child and have access to our unlimited number of question and answer exercises. Visit www.smartchildzone.com.